Now let us see first example on strain energy and impact loading. A vertical steel bar of length 1.5 meter is fixed at top. When weight falls through height of 40 mm, the maximum instantaneous stress developed in the bar is 200 MPa. Determine the stress in the bar when the same weight is gradually applied, suddenly applied, and with a free fall of 50 mm. So there are three cases: gradually applied, suddenly applied, and with a free fall of 50 mm. But the first case is also as that of the impact loading because weight is falling from certain height of 40 mm. So length is given as 1.5 meter. Convert meter into mm by multiplying by 10 raised to 3. H is 40 mm. Maximum instantaneous stress is 200 MPa. MPa means Newton per mm square. Now for the impact load with this height of fall is equal to 40 mm. Now impact load means what? The load which is falling from a certain height is known as the impact loading. So here we'll use the plus sign in the equation for the maximum instantaneous stress. So our design will be on the basis of maximum value. Now let W upon A is equal to X. So we can say that sigma max will be equal to, in place of W upon A, substitute X plus 2 into. Now this W upon A is X. So it is 2xh E upon L, and W upon A and square of that. So it is as good as x square because W upon A is nothing but x that we have assumed. Transfer this x on this side, so it will become minus or negative, and square root will remain on the right hand side as it is. Now squaring both the sides. So we have to remove this square root and therefore we are squaring both the sides. So therefore sigma max minus x whole square will be equal to, square it will go from this side. So it is only 2x he by L plus x square. Now square this particular term. It is a minus b bracket square, that is a square minus 2ab plus b square, 2xhe upon L plus x square as it is. This x square and this x square will get cancelled because plus x square will come on this side, it will become minus x square and then will get cancelled out. So this is sigma max square will be equal to 2xhe by L. Transfer this minus term on the other side, it will become plus. This x square as it is, and we have transferred this plus x square on this side, so it will be minus. So once again try to understand. We have kept this term as it is on this side and we have transferred this minus term on the other side, it will become positive. This plus x square on the other side, it will become negative, and this right hand side as it is. So right hand side is 2xhe by L plus x square, though that is represented by these two terms. Minus term will come on this side, it will become positive, and this plus term will come on this side, it will become negative, and this plus x square and this minus x square will get cancelled. So that we are having now only these two terms. Take x common from this, so it is 2he by L plus 2 sigma max. So sigma max square divided by this entire bracket will give you the value of x. Substitute the values. So sigma max is 200 and square of that 2 into height of the fall is 40 mm. Modulus of elasticity, if not given, you can assume this value 200 into 10 raised to 3 for steel. Length, it is 1500 mm plus 2 into sigma max, that is 200 MPa or Newton per mm square. So do the calculations for this and you'll get value of x as 3.62 MPa. Now, when the load is applied gradually, we know that instantaneous stress developed is W upon A itself. So that value will be equal to 3.62 MPa. When the load is applied suddenly, then we know that sigma max is 2 times W upon A. So it is 2 into 3.62. So that is 7.24 MPa. 2 into 3.62, that is 7.24 MPa. And the last case is that it is the case of load falling from a certain height, that is impact loading. So H is equal to 50 mm. So sigma max will be equal to W upon A plus square root of WHE upon AL plus W square upon A square in the under root. W upon A is nothing but X. So this is 2XHE by L plus X square. Substitute the value of X. So W upon A is X. W upon A bracket square, that is X square. And this is also X. Substitute all the values. In place of X it is 3.62. Here it is 3.62. H is 50. E is 200 into 10 raised to 3. And length is 1500 mm plus X square, that is 3.62 square. So the stress that is induced because of this impact loading will be 223.35 MPa or Newton per mm square.